Okay, thank you. All right, thank you for the introduction. So, despite I'm a cryptographer, I won't be talking much about cryptography this time, but I'll be talking about Ethereum nodes and what troubles they bring us when we try to actually build a mixnet or an incentivized mixnet, that's what Hopper is, on top of Ethereum. So first of all, just a really short introduction just to let you understand why do we actually need an Ethereum node in a thing that is a mixnet, right? Because Hopper is a mixnet which is also incentivized. Incentivized mixnet it's like a new generation, let's say, of mixnets. If you think about it, you probably know about Tor. Tor is not a mixnet, but it kind of tries to achieve the same goal as mixnets do. So it creates it has a network of nodes, and these nodes actually are able to bring privacy and anonymity to your standard network communication, so web browsing, VPNs, stuff like that. Hopper is actually a mixnet, which means it's better in terms of privacy, and also it's incentivized. And this incentivization is actually what brings us to Ethereum, right? So when the Hopper protocol gives you privacy, it basically relays your communication through the set of nodes. These nodes are called the relayers. And these relayers do their work, basically forwarding the packets to the next hop, and over 3 or more hops, you get a certain degree of privacy. The word incentivized means that these relays also get a reward for their job they're doing. So it's kind of like a self-sustaining economy. You're getting anonymity, and you pay the relayers to give you the anonymity. And that's why these relayers, because Hopper protocol is deployed over Ethereum, so not on the mainnet, but currently on Gnosis chain, but it needs to interface with blockchain somehow to be able to see the reality of the on-chain data, right? So there is certain information about the relayers, which the relayers could also use to claim their reward. So you can imagine this simple graph here, or this simple diagram. I'm a sender, and there are 3 layers on my way to the recipient. And these little arrows is not just where the data flows, like the data which I'm requesting from the recipient or I'm sending to the recipient, and the recipient sends me something also back through a different path. But these arrows also indicates where the payments to the relayers for giving me the anonymity flow. So this is not just where the data flows, but also where funds are flowing. So think of them as payment channels that are between the relayers and senders and recipient. And these payment channels basically allow us to make a settlement, because if relayer A does its job of relaying some data, it's eligible to get a reward for that. And because of that, every relayer and participant in the network has to be also seeing the reality of the blockchain, like what settlement has been done, where is a payment channel, how much there is still funds on a payment channel. And this is done by these nodes actually being relying on an RPC, on Ethereum RPC node, right? So they could be, each and every one of them, using different RPC. Some of them could be even using a local RPC. Some of them might be using a third-party public RPC. You probably know a bunch of them. But the problem is that it turns out that these nodes, when interfacing with a blockchain using an RPC, might not be actually all of them seeing the same reality. We've spent many hours, days, weeks debugging issues which we thought originally that were in the actual protocol, but they turned out to be problems within these RPCs that these nodes were actually observing. And this is what I'm be talking about and showing you how you should not be trusting these RPCs blindly, right? what's the consequences of these RPCs? And we are talking about different execution clients. It's not about a specific one. It could be Reth, Nethermind, Aragon, Geth, you name it. And also, what's important, the issues that I'll be talking about are not just happening when you look using third-party public RPC. It could also very well happen, and it does happen even if you use your local RPC, your full Ethereum node, which you are running in your own infrastructure, let's say. What are the consequences of the RPC feeding us invalid data? These are kind of serious privacy-related consequences. It could also mean that the nodes might not be able to see each other, because in our case, blockchain is also used for the discovery of the nodes. So that means that your anonymity set of the mixnet actually decreases. And that means that you're less private when there's less nodes, and there's less of them because you're just not able to see them because your RPC is faulty, right? Different problem might be that communication might fail because your RPC is telling you, okay, there are no more funds in this payment channel, so you cannot use this route to actually send the traffic, but in fact, there are funds, right? So again, it reduces your anonymity set. Nice, a third example would be that because the RPC is feeding you faulty data, you might not be able, as a relayer, to extract your reward from the system, right? Although you are still eligible perfectly. Most often, all of these, when RPC is feeding you faulty data, these happen, all of them, at the same time. And there is like a domino effect, and all that you see at the moment is basically your network starts shrinking. The problem is how we tend to think about the Ethereum nodes, about the RPC, about execution clients. So we still think that RPC is a server basically to a remote database, that database being the blockchain itself, right? So we also expect that the RPCs, all of them, see the same data or are feeding you the same data. We also expect these queries, RPC calls to the Ethereum nodes, behave pretty much like queries to an SQL database, right? And also, another thing is that we somewhat think that these retrievals are always reliable. You're always going to get the right data, deterministic data, and you get the data within an acceptable delay. It turns out that none of this is actually true. So let me show you where it all began, actually. So it began roughly in less than a year ago when we started seeing problems, because before we thought these problems were in our protocol, and we realized actually it's not. It's one of the problems back then was that ETH-GET logs on certain Ethereum nodes was not giving us the right data. It was even feeding us empty results. And it was a little bit strange, so we started filing a bug to Nethermind, Aragon. It's not just related to a single specific execution client. It actually happened on many of them. Just to give you a better understanding what ETH-GET logs does, it's like the single most important call, or one of the most important calls you could do from an RPC. So let's say, as a simple example, you are building a wallet, right? So you want to build a wallet, and the first thing you do, you want your wallet to show a balance of some token, right? So it does an RPC call to an RPC, which is ETH call. It fetches you, I don't know, you have there 100 USDC, for example. And the second feature in your wallet, you want to have a list of transactions that happened with your wallet, with the token, with that specific token. So you call ETH-GET logs to get the historical data out of the chain. And then you realize, because ETH-GET logs is failing, that the history of transaction simply does not add up to the 100 USDC that you fetched at the beginning. So this is, if this is wrong, this is a fundamental problem in what the RPCs are feeding you, or what these RPCs are, or how these RPCs are behaving. So let's take a look at one of the first problems, to be specific. So here we have the same RPC requests One is to a Nethermind client running on a third-party RPC publicly. Second one is running locally. And what the problem here is, with the same RPC queries, you are getting completely different block hashes. That shouldn't happen, right? So just to further give you a simple analogy, let's, for example, imagine that blockchain is an SQL database, right? Blockchain is an SQL database. You have an SQL client, and you do select a hash from blocks from a certain block number. And that client gives you some hash. Then you have a second client, also connected like a second RPC, connected to the same blockchain, quote-unquote, SQL database. You do the same query, you get a completely different hash. So this behavior, I would say, we wouldn't deem as acceptable from SQL databases. But it is actually sometimes a reality of the RPC nodes, right? Another example, here we request using eth-get logs, certain logs from a certain block, from one specific certain block. And you could see that in these responses, this log is actually back-referencing to the block it belongs to. But you see, although they belong to the same block, the back-reference to the block hash are actually different in the responses. Even that the block number you see is the same one. So again, if I use this stupid analogy with blockchain being an SQL database, it's as if I did an SQL query saying, give me a log index and block hash from blocks where there is a certain block number, from a certain block number. I'm going to get two responses back, two rows, two logs, but although they're from the same block, they back-reference to an invalid hash, a different hash. So then a question like, which one is actually, this shouldn't happen, right? This is not what you would be expecting. Second thing, or third thing that we encountered pretty much a lot is that the RPCs were randomly timing out on the same queries, sometimes giving us the right response, but sometimes timing out on the same query. Again, with this analogy would be you do a select, once you get your data, and when you do the next time, you get a timeout. So you could ask yourself, if you are going to be building an application on such an SQL database, would this ever lead to a good UX in your application? I would say absolutely not, right? Although this is the stuff that we keep seeing on RPCs. It doesn't matter if that RPC is a public one or if it's a local one. These things happen even if you run things locally, your local Ethereum node. And there's more. There is missing data completely from the Ethereum nodes. There are internal server errors. That's a classic, of course. That's, I would say, a little bit of a niche because that's on a trace transaction call. But often you get complete responses which are from two conflicting blocks on the same block height. Sometimes you get a response that is incorrect, has incorrect index and block hash. So all of these were actually bugs that we encountered, and we reported every single one of them to the respective teams on Nethermind, Aragon, whatever execution client we have encountered these errors. Yeah, some of them are resolved, some of them are not. It's a continuous process. Nethermind was one of the most attentive teams, which was helpful, and they closely cooperate with Tenderly. What also Nethermind did in order to kind of work around these errors, or errors like these, they introduced a new parameter to the Nethermind node, which when you specify, it basically runs two separate database indices to index their internal representation of the chain data, and then cross-compare when you do a request to see if there is a discrepancy. So it's not really a fix, it's rather a workaround. So let's say if there is a discrepancy between these two indices internally, it's going to give you an error, or it could even prioritize one index over the other. So it's not a fix although it's like at least a step in acknowledging that there is a problem of how these Ethereum nodes actually internally represent the chain data, which is then used when you query over the RPC endpoint. We also, what we did, we developed our custom tooling because we realized, okay, this is a fundamental problem that we cannot really do much about it unless these teams actually fix that. We did an RPC debugging tool, or it's an RPC proxy debugger. It basically monitors multiple different instances of different RPC or execution clients. So let's say you have Nethermind across different versions, you have different versions of Aragon, Reth, Geth, and we compare the discrepancies between the responses to the same requests that we make to them. This tool is available, although I would encourage you, especially now in the era of AI, to actually build your own tooling, because this might be too specific for our use case, because we use ETH-GET logs quite a lot. But in your case, when you're developing an application, you might be using a completely different RPC call. So the conclusion from this would be you should be verifying what the RPC nodes are feeding you. That's one of the most important things, because there's always going to be bugs. But the issue being that we might be trusting the RPCs giving us the right data. And the worst part about it is these discrepancies are often barely noticeable. So you think you're getting the right data, but in fact, you're not. And only on the long term, like we did in the Hopper network, we started seeing problems with payment channels, nodes missing from the network completely, and overall worsened UX, which was traced all the way back to the actually RPCs not giving or not doing the right job. This is, however, a fundamental problem in Ethereum, right? There's missing test coverage in all of the execution clients out there. They're missing acceptance tests for the execution clients. There's a thing, though, called Hive, which is a test suite that the execution clients run, but they are really not enough, right? For example, for ETH-GET logs, there are only 4 tests, and that's the single most important, or one of the most important RPC calls. And they no way cover all the possible scenarios and situations of how these calls are actually used in the wild, right? For example, we've encountered, like if you do ETH-GET logs on a single block, most of the time you get the right response. But the most errors we encountered when we actually fetch across larger ranges of blocks or even historical blocks, and that is nowhere tested in Hive, for example. There's a nice post about this on ETH Research. It's called Ethereum Needs Standards, and this is about that we're missing actually the larger suites or general Ethereum compliant tests for the execution clients and the RPC software in general. Another thing is that you should be, as I said already, you should be encouraged to build your own tools that maybe more closely fit your use cases, but you could still use the RPC proxy debugger that we did. It might give you clues of some errors which you had no idea where these errors were actually happening. And lastly, it's always important, do report these issues to the RPC teams. They really, at least from the Nethermind side, they were really fixing them or trying to fix them. In some of these issues, they even acknowledge them, but they have no idea why they're happening, but they're at least trying to do something about it. At least in our case, it was helpful because all of these issues that I showed you today were reported. They were acknowledged that they actually happened, and they're continuously being fixed. And I think that's about the end of the talk, so thank you a lot for attention.